In the previous lecture, we see the examples in the exercise 4.2. The examples on the definite integral by using the fundamental theorem of the integral calculus. Now, we see the second example in this exercise. Here, evaluate the first problem. Integral 0 to 1 by root 2. 0 to 1 by root 2 sine inverse x upon 1 minus x square to the power 3 by 2 dx. Now, it is an example. Okay. Here, we know that how to find the definite integral. Okay, we can solve the integral by using the method of the indefinite integrals, and lastly, in the definite integral, we put the values of the x, that is, it is a limit 0 to 1 by root 2. Here, in the definite integral, we know it is the integral of f of x is equal to g of x, and here it is a plus c. It is an indefinite integral. Now, in definite integral, integral a to b f of x dx. Here, integral of g, it is f of x is g of x, and it is a limit a to b, and then we can solve it is the upper limit minus lower limit. Okay. Here it is the definite integral. Okay, indefinite integral, here we can find the integral by using the method of indefinite integrals. Okay, we can find directly the integrals, and then in the definite integral we put the limit, it is a lower limit and it is upper limit. First we put the upper limit and then lower limit. Here it is a to b, it is the values of the x, a to b. Here the function, it is a f of x. Okay, and it is a to b, it is the values of the x belongs to closed interval a comma b. Now here the limit 0 to 1 by root 2, 0 to 1 by root 2, that is the x belongs to 0 comma 1 by root 2. Okay, and this integral, but here this integral we cannot be solved by directly. Here this integral we can solve by using the substitution method. Okay, and in the substitution method there is a small change. Okay, what is the change we see in this example? Okay, see carefully. Okay, same example. Okay, solution is the same as indefinite integral, and in the definite integral there is a small change. Okay, here it is a limit 0 to 1 by root 2 in this integral. The value to find this integral by using the indefinite method of the indefinite integral, that is, this problem we solve by using the substitution. Okay, see carefully. Okay, here solution, it is I is equal to integral 0 to 1 by root 2. Here it is a limit, that is all possible values of x. It is a 0 to 1 by root 2. In this example, it is a x belongs to 0 to 1 by root 2. Okay, here it is upper limit, so it is lower limit and it is a upper limit. Now it is sine inverse of x upon 1 minus x square to the power 3 by 2. Here it is a power 3 by 2. This power 3 by 2 we can write integral 0 to 1 by root 2 sine inverse x upon, here x 1 minus x square to the power 3 by 2, this can be written, it is a 1 minus x square into under root 1 minus x square. Here the power of this 1 minus x square, it is 1, and power of this 1 minus x square, it is a 1 by 2, and base same rules of the indices, addition of the powers, 1 plus 1 by 2, it is a 3 by 2. That means we can write this 1 minus x square to the power 3 by 2 in the form of this. Now here we put the substitution. Okay, put sine inverse x is equal to t, and the sine inverse derivative of the sine inverse x in the multiple of dx, it is a 1 by under root 1 minus x square. So here we put sine inverse x, it is a substitution. Put sine inverse x is equal to t. Okay, therefore x is equal to sine t. Sine inverse x is equal to t, therefore x is equal to sine t. Then we can find the derivative. It is 1 upon under root 1 minus x square, derivative of sine inverse x, and it is a dt by dx. So we can write it is a dx is equal to dt. Okay, now it is a substitution. Then this integral becomes here integral 0 to 1 by root 2 t sin inverse x is it is a t upon 1 minus x square, it is a 1 minus sin square t, x is equal to sin t, and it is 1 upon under root 1 minus x square, that is dx upon under root 1 minus x square, dx upon under root 1 minus x square, it is a dt. See carefully this. Okay, here in indefinite integral we can solve the integral by using this method. Okay, and solve. In the definite integral there is also we can solve this integral by using this method. Here we can solve this, again integrate. Okay, but here see carefully, here it is a definite integral. What is 0 to 1 by root 2? 0 to 1 by 2, it is a all possible values of the x. It is a f of x. Okay, function of x, and the domain of x for this example it is a 0 to 1 by root 2. It is a 0 to 1 by root 2. 0 it is a to b, it is all possible values of x. 0 to 1 by root 2, all possible values of x, but this is the function of t. This is a function of t, and it is the values of x. Okay, it is f of t. So here we can write the values of t by using this substitution. When sin inverse x is equal to t, then x is equal to sin t. Okay, by using the values of x, we want to first find the values of t. Here it is a function of t, so here we cannot write the limit of the x. It is the values of x, 0 and under root 1 by under root 2, it is the values of x. But here function is in t, so here we can write the values of t. Okay, see carefully. Okay, we cannot write the values of x. Okay, in the definite integral it is a small change. Okay, change the limit. Here it is the values of x, here we can write values of t. Okay, values of x, it is a 0 and 1 by root 2. Okay, change the limit. In the substitution, see carefully, when x is equal to 0, 0 and 1 by root 2, when x is equal to 0, it is a t is equal to, see carefully, when x is equal to 0, we want to find the value of t, and it is a t, sin inverse x is equal to t. When x is equal to 0, that means we put the value of x, it is a 0, sin inverse of 0, sin inverse of 0, it is a 0, so it is a t is equal to 0. When x is equal to 0, t is also 0. Now when x is equal to 1 by root 2, see carefully, when x is equal to 1 by root 2, x is equal to 1 by root 2, that is sin inverse of 1 by root 2, sin inverse of 1 by root 2, and sin inverse of 1 by root 2, it is pi by 4. That means it is a sin inverse of 1 by root 2. When, see carefully, it is x is equal to 0, here sin inverse of 0 is equal to t, that is a 0. When x equal to 0, t equal to 0. When x is equal to 1 by root 2, t is equal to sin inverse of 1 by root 2. Okay, t is equal to sin inverse x. Therefore t is equal to sin inverse of 1 by root 2, and it is a pi by 4, and therefore t is equal to pi by 4. Okay, now for the x it is a limit 0 to 1 by root 2, and for the t here it is a limit 0 to pi by 4. Okay, here this step is a very important in the definite integral. When we use the examples in the definite integral by using substitution, change the limit. When we substitute, change limit. It is problem in the variable x, we can substitute, it is a t. Therefore we know the values of x. By using the values of x, we find the values of t and put this. Okay, remember this only one step, and it is a very important. Okay, changes of the limit. First, in the example there is a given 0 to 1 by root 2, and here it is a 0 to pi by 4. Okay, 0 to 1 by 2 replaced by 0 to pi by 4. When x is equal to 0, t is also 0. But when x is equal to 1 by root 2, t is equal to pi by 4. See carefully this. Okay, here डेफिनाईट इंटिग्रलच्या प्रॉब्लेममध्ये एक स्टेप ही केअरफुली लक्षात राहू द्या. जेव्हा जेव्हा तुम्ही सबस्टिट्यूशन करणार तेव्हा लिमिट चेंज करायचं. कारण सुरुवातीला फंक्शन आहे एक्स, ह्या व्हॅल्यूज आहेत एक्सच्या, पण आता तुमचं फंक्शन झाले टीमध्ये, मग फंक्शन टीचं आहे तर एक्सच्या व्हॅल्यू यूज करता येणार नाहीत. इथे व्हॅल्यू कोणत्या पाहिजे तुम्हाला? टीच्याच व्हॅल्यू पाहिजेत. मग तुम्हाला लिमिट चेंज करायचं आहे. एक्सच्या जाग्यावर, एक्सच्या व्हॅल्यूच्या जाग्यावर कोणत्या व्हॅल्यू लिहायच्यात? टीच्या. ही स्टेप सगळ्यात महत्त्वाची. ओके, डेफिनाईट इंटिग्रल काहीही असो, कोणताही प्रॉब्लेम असू द्या. याच्या आधीचे आपण डेफिनाईट इंटिग्रलचे प्रॉब्लेम केलेत, त्याच्यात काय केलेले? सरळ त्याचा ॲन्सर काढला आणि लास्ट ॲन्सरमध्ये काय केलेले? लिमिट पुट करून दिलं. दॅट इज अपर लिमिट मायनस लोअर लिमिट. डायरेक्टली सॉल्व्ह केला प्रॉब्लेम. ओके, पण सबस्टिट्यूशननं जर प्रॉब्लेम सॉल्व्ह करीत असले तुम्ही, इंटिग्रेशन बाय सबस्टिट्यूशन, तर लिमिट चेंज करायला विसरायचं नाही, कारण तुम्ही व्हेरिएबल चेंज करायले. ओके, हिअर एक्स व्हेरिएबल अँड हिअर इट इज अ टी व्हेरिएबल. ओके, हे केअरफुली लक्षात राहू द्या. इथून पुढचा कोणताही प्रॉब्लेम असू द्या, सबस्टिट्यूशन केलं, पुट केलं सबस्टिट्यूशन की लिमिट चेंज करायचं. डेफिनाईट इंटिग्रेशनच्या प्रॉब्लेममध्ये हा एवढा एकच चेंज. बाकी सगळे प्रॉब्लेम तुम्ही काय इंटिग्रेशनच्या मेथडनं सॉल्व्ह केले. सगळ्या इंटिग्रेशन प्रॉब्लेमचंच रिव्हिजन करायचं आपण. प्रत्येक प्रॉब्लेम तेच सॉल्व्ह करायचं आहे आणि लास्टला लिमिट ठेवायचे. फक्त सबस्टिट्यूशन केलं तर लिमिट चेंज करायचं विसरायचं नाही कोणत्याही प्रॉब्लेमला. याच्या पुढे लक्षात राहू द्या. आता कोणताही प्रॉब्लेम सबस्टिट्यूशनचा आला, इंटिग्रेशन बाय सबस्टिट्यूशन, की लिमिट चेंज करायचं आणि त्याच्यानंतर मग इंटिग्रल सॉल्व्ह करायचं. आणि इथं टी आहे तर टीच्या जागेवर लिमिट ठेवून द्यायचं. ओके, नाव वी कॅन सॉल्व्ह दिस एक्झाम्पल. here integral 0 to pi by 4 t upon 1 minus sin square t, and then it is integral 0 to pi by 4 t upon, it is a cos square t dt. 1 minus sin square t, it is a cos square t. Now this can be written, it is a integral 0 to pi by 4 t into sec square t dt. Carefully पहा, t upon cos square t, and it is 1 by cos square, it is a sec square. Okay, t into sec square t, and now integral of this function t into sec square t by using the integration by parts, that is a u into v. Okay, and here limit it is 0 to pi by 4. Okay, by using the u into v we can find the integral. See carefully, u into v, it is a t into integral of sec square t dt minus integral of derivative of t into integral of sec square t dt, and it is a dt. Okay, here it is a u into v, u into integral of v minus derivative of u into integral of v, it is integral of derivative of u into integral of v. Now we can solve this, and here it is a limit 0 to pi by 4. Okay, remember this. Here it is a t, it is sec square t, it is a standard integral, that is a tan t minus integral of derivative of t, it is a 1 into tan t and dt. And now here t into tan t minus integral of tan t, it is log of sec t. Integral of tan t, it is a log of sec t. See carefully here, and it is a limit 0 to pi by 4. Okay, it is a definite integral, so we cannot write plus c. Okay, here we put the limit, it is a 0 to pi by 4. Limit 0 to pi by 4. Now first we put the upper limit, then lower limit. See carefully. First upper limit, pi by 4 into tan pi by 4 minus log of sec pi by 4 minus lower limit, it is a 0. Okay, here we can write here minus lower limit, it is a 0 into tan 0 minus log of sec 0. Here it is upper limit minus lower limit. In the upper limit we can replace t by pi by 4, and here replace t by 0. It is a 0 is a lower limit and it is a upper limit. Now calculate. Here it is a pi by 4 into tan pi by 4 it is 1 minus log of sec pi by 4 it is under root 2 minus it is a 0 and again minus this plus sec 0 it is 1, therefore it is a log 1 and we know that the value of log 1 it is a 0. Okay, therefore it is a pi by 4 minus log under root 2 and it is plus 0. Okay, and then the last answer it is pi by 4 minus log under root 2. Okay, here see carefully डेफिनाइट इंटिग्रल. आता याच्या पुढच्या प्रत्येक प्रॉब्लेमसाठी एकच गोष्ट लक्षात राहू द्या, लिमिट चेंज करायला विसरायचं नाही. आपण सबस्टिट्यूशन केलं की लिमिट चेंज करायचं विसरायचं नाही, हे सगळ्यात महत्त्वाचं लिमिट चेंज करणं. कारण तुम्ही व्हेरिएबल बदलायले म्हणजेच त्याच्या व्हॅल्यूसुद्धा बदलणार. हे एक्सच्या व्हॅल्यू एक्ससाठी लिमिट आणि इट इज टी. ओके, एक्सच्या व्हॅल्यू दिलेले असतात, सबस्टिट्यूशन केलेले त्याच्यावरून काढणार टीच्या व्हॅल्यू. ओके, केअरफुली पहा प्रॉब्लेम. ओके, नाव यू सी नेक्स्ट एक्झाम्पल. Example number 2, integral 0 to pi by 4 sec square x upon 3 tan square x plus 4 tan x plus 1 dx. Now here the integral solution we can write here. Integral is equal to 0 to pi by 4 sec square x upon 3 tan square x plus 4 tan x plus 1 dx. Here in the multiple of dx there is a sec square x and sec square x is a derivative of tan x. So here we use a substitution, tan x is equal to t. Put tan x is equal to t. Okay, then tan x is equal to t, sec square x dx is equal to dt. And now here it is a definite integral and here we use the substitution, so change the limits. When x is equal to 0, t is equal to, here it is a t is equal to tan x is equal to 0, therefore tan 0, t is equal to tan 0 and then it is tan 0, it is a 0. And when x is equal to pi by 4, when x is equal to pi by 4, that is tan pi by 4 and tan pi by 4 it is 1, therefore 1 is equal to t. When x is equal to pi by 4, t is equal to 1. Now here original limit it is 0 to pi by 4, we change the limit, it is 0 to 1 for using this substitution, and therefore integral is equal to 0 to 1, it is 1 upon 3t square plus 4t and plus 1 sec square x dx, it is a dt. Okay, 3 tan square x plus 4 tan x plus 1. Okay, and sec square x dx is equal to dt. Now it is an integral of the type 1 upon quadratic function. We solve this type of the integral by using the completing square method. Okay, for the completing square, first it is we take the common 3, the coefficient of t square, take a 1, therefore it is a 1 by 3 into integral of 0 to 1 upon t square plus 4 by 3 t and plus 1 by 3. Okay, now the coefficient of t, it is a 4 by 3. Again here it is a 1 by 3 integral of 0 to 1 upon t square plus 4 by 3 t and plus the half of the 4 by 3, coefficient of 4 by, it is a t, it is a 4 by 3, half of 4 by 3, it is a 2 by 3, and square of 2 by 3, it is a plus 4 by 9 minus 4 by 9, and it is a plus 1 by 3 as it is, and it is a dt. Now it is a 1 by 3 integral 0 to 1, okay, 1 upon, see carefully the calculation, t plus 2 by 3, t plus 2 by 3 square, it is a t plus 2 by 3 square, and here it is a minus 4 by 9 and it is a plus 1 by 3. There is a common 3, and here remaining 1 and here remaining 3. See carefully. In the denominator we take common 3 element, okay, and then it is 1 remaining here 1, and here it is a 3. 1 into 4, it is a minus 4, and 3 into this 1, it is a plus 3. Minus 4 plus 3, it is a minus 1. In the numerator we can write minus 1, and in the denominator common factor and remaining factor, the product of common and remaining factor, then it is a minus 1 by 9, and it is a dt, okay, and then this can be written 1 by 3 common as it is into integral 0 to 1 upon t plus 2 by 3 square and minus 1 by 3 whole square dt. And now here we use 1 upon x square minus a square, that is 1 by 2a log of x minus a upon x plus a. Okay, here we use the standard integral. Here 1 by 3 as it is, then 1 by 2a, 1 by 2 into 1 by 3, 2a, it is a, log of x minus a upon x plus a, it is a formula, okay, and here limit, it is a 0 to 1, okay, see carefully, it is an integral, okay, and it is limit 0 to 1. Now we calculate this. Here 1 by 3 and these 3 cancel, so here remaining only 1 by 2 we can take outside, and here log of, see carefully this, here 2 minus 1, it is a 1 by 3, it is 1 by 3, and it is a 4 by 3, okay, and we multiply by 3 numerator and denominator, therefore here 3t plus 1, here 2 minus 1, it is 1 by 3, and multiply by 3, it is a 3t, and here 3 cancel, it is only 1, and in the denominator again same, 3 plus 1, it is a 3 plus 1, it is a 2 plus 1, it is a 3, and 3 upon 3, it is 1, and we multiply by 3, so we can write here 3t plus 3, and limit 0 to 1. See carefully this calculation, okay, here now we put the limit, first we put upper limit and then lower limit, then it is 1 by 2, first we put the upper limit, that is log of 3 plus 1 upon 3 plus 3, we put the 1, okay, and minus lower limit, log of 0 plus 1 upon 0 plus 3, upper limit minus lower limit, first we put t is equal to 1, then it is, when we put t is equal to 0, it is 0 0, and then we calculate 1 by 2, it is log of 4 upon 6, see carefully, it is 4 upon 6, that means 4 upon 6, it is a 2 by 3, 4 upon 6 minus log of, it is a 1 by 3, and here we use the property of logarithm, that is 1 by 2 log of 2 by 3 upon 1 by 3, and then the last answer, it is 1 by 2 log 2, 3 get cancel, it is a 2 by 1, and that is log 2. 1 by 2 log 2. It is the last answer of this question. See carefully. When we use substitution, change the limit. First it is a 0 to pi by 4, and after substitution limit it is a 0 to 1, and we can solve by using this. Okay. Example, by completing square method, फक्त इथे limit put करत, upper limit minus lower limit. Okay. See. Now next example. Example number 3. Integral 0 to pi by 4 sin 2x upon sin to the power 4x plus cos to the power 4x dx. Here it is a sin 2x into dx, that is a multiple, in the multiple of dx there is a sin 2x, and we know that sin 2x, it is a derivative of sin square x or cos square x. Derivative of sin square x, it is a sin 2x, and derivative of cos square x, it is a minus sin 2x. Derivative of sin square x, it is a 2 sin x into cos x, that is the sin 2x. Or derivative of cos square x, it is 2 cos x into minus sin x, it is minus sin 2x. That means sin 2x is a derivative of sin square x, either cos square x. Okay, we put sin square x is equal to t or cos square x is equal to t. Okay, here, but here it is a sin to the power 4 and it is a sin to cos to the power 4. Okay, see carefully. First it is integral 0 to pi by 4, it is sin 2x upon sin to the power 4x plus cos to the power 4x dx. We convert sin x into cos x or cos x into sin x. We convert all terms in the form of the sin square or all terms in the form of the cos square. Okay, here we write all terms in the form of the sin square. See carefully this. Integral 0 to pi by 4 sin 2x upon, it is sin square x whole square plus cos square x whole square dx. Now integral 0 to pi by 4 sin 2x upon sin square x whole square plus 1 minus sin square whole square dx. Okay, here there, now here we put sin square x is equal to t, it is sin square. Here put sin square x is equal to t, then derivative of sin square x, it is a 2 sin x into cos x is equal to dt by dx, and therefore it is sin 2x dx is equal to dt. It is a sin 2x, you can write dx and this sin 2x dx is equal to dt. Now here we use substitution, it is a definite integral, so we use change the limits. When x is equal to 0, t is equal to, when x is equal to 0, it is a t is equal to, see carefully, t is equal to sin square x is equal to 0, here it is a sin square 0, sin 0 is a 0, therefore sin square 0 is also 0. When x is equal to pi by 4, when x is equal to pi by 4, it is a sin pi by 4, and sin pi by 4 it is a 1 by root 2, but it is a sin square, so here 1 by root 2 square, it is a 1 by 2. Therefore t is equal to 1 by 2. Original limit 0 to pi by 4. Here after substitution it is a 0 to 1 by 2. So we can write it is the integral 0 to 1 by 2. 0 to 1 by 2. It is a 0 to pi by 4. And now here sin 2x dx, it is a dt. Therefore it is a 1 upon t square. Sin square x is equal to t. Therefore it is a t square plus 1 minus t whole square. It is a sin square is equal to t. Therefore it is a t square. Sin square x is equal to t, 1 minus t whole square dt. Okay. Now we calculate this. It is a 0 to 1 by 2, 1 upon t square plus 1 minus 2t and plus t square. Expansion of this bracket. Okay, 1 minus t whole square, 1 minus 2t plus t square, and then this can be written. It is a integral 0 to 1 upon 2t square minus 2t, and it is a plus 1 dt. See carefully this. It is a 0 to 1 by 2. Okay. 0 to 1 by 2. It is a t square. It is a 2t square minus 2t, and it is a plus 1. Okay. Again it is a 1 upon quadratic function. This integral we can solve by using completing square method. For the completing square, first we take common this 2, that is the coefficient of the t square. Then integral is equal to, here 1 by 2 we can take 2 common. 0 to 1 by 2, it is a limit 1 upon t square minus t and plus 1 by 2 dt. When we take 2 common, it is a t square, it is a t, and it is 1 by 2. Now by completing square method, it is a 1 by 2 into integral 0 to 1 by 2, 1 upon here t square minus t and plus coefficient of t 1, half of 1, it is 1 by 2, and square it is 1 by 4. Therefore plus 1 by 4 minus 1 by 4, and it is a plus 1 by 2 as it is dt. Then it is a 1 by 2 into integral 0 to 1 by 2, 1 upon it is t minus 1 by 2 whole square. First 3 terms are the complete square, and here minus 1 by 4 plus 1 by 2. Here minus 1 by 4 plus 1 by 2, it is a plus 1 by 4, plus 1 by 4 dt. And here it is a plus 1 by 4, means 1 by 2 square. See carefully, it is plus 1 by 2 square. Now it is 1 upon x square plus a square. It is a special integral. 1 upon x square plus a square. It is a 1 by a tan inverse x by a. So the integral is, it is a 1 by 2 as it is, into 1 by a. It is a tan inverse x by a. It is a t minus 1 by 2 upon 1 by 2. And here it is a limit 0 to 1 by 2. Okay, and now this 2, it is, that is 1 by 2, 1 by 2 get cancelled, or when we multiply this 2 to get cancelled. Here it is 1, and it is a tan inverse of here 2t minus 1, 2t minus 1, 2t minus 1 upon 2 get cancelled. Here 0 to 1 by 2. It is an integral. Now we put the upper limit minus lower limit, and then it is tan inverse of, see carefully this, when we put the upper limit 1 by 2, it is a 2 into 1 by 2, it is a 1 minus 1, tan inverse of 0 minus 1. Okay, here 2 to get cancelled, here it is 1, that is 1 minus 1, it is a 0, it is a tan inverse 0 minus tan inverse of minus 1, and tan inverse of 0, it is a 0, but here tan inverse of minus 1, it is a plus tan inverse of 1. Okay, tan inverse of minus x, it is minus tan inverse x, and then 0, and it is tan inverse of 1, it is a pi by 4. tan inverse of 1, it is pi by 4. That is the answer of this question. It is a pi by 4. Here we use the substitution sin square. First we simplify, then substitution, and then it is a type. Okay. इंटिग्रेशनचा कोणताही प्रॉब्लेम सॉल्व्ह करण्यासाठी तुम्हाला 3 स्टेप सांगितल्या होत्या. प्रॉब्लेम पहा, प्रॉब्लेम काय टाईपमध्ये असला तर सरळ सॉल्व्ह करायला सुरू करा टाईपच्या सोल्युशननुसार. टाईपमध्ये नसला तर मग सबस्टिट्यूशन, आणि सबस्टिट्यूशन नसलं तर सिम्प्लिफिकेशन. मग आता इथं काहीच नाही, तर सगळ्यात आधी आपण सिम्प्लिफिकेशन केलं. सिम्प्लिफिकेशन केल्याच्यानंतर आपल्याला सबस्टिट्यूशन करता आलं, आणि सबस्टिट्यूशन केल्याच्यानंतर टाईपमध्ये प्रॉब्लेम आला. ओके. हियर नाउ वी सी नेक्स्ट एक्झाम्पल. Example number 4, integral 0 to 2 pi under root cos x into sin cube x dx. Again here in the integral there are the composite function, but the derivative of cos x is not sin cube x, or the derivative of sin x or sin cube x, it is not under root cos x. First we here the simplify and then use the substitution. It is integral is equal to 0 to 2 pi under root cos x into sin cube x dx. Okay, now here we cannot write cos x in the outside the integral. Okay, so here we use the integral of, sorry, it is a derivative of cos x, it is a sin x, and here it is a sin cube, so this spread it is a sin square x into sin x. Here there are both are the sin and cos, both are the composite function. In the substitution we put the composite function. Okay, to find the integrals of the composite function we use the substitution method. Okay, and here both are the composite function, we put either sin or cos, but here it is a derivative of sin x, it is a cos x, we cannot cos x write the outside the this under root, but the derivative of cos x it is a minus sin x, that is the derivative of sin x in terms of the sin x, we can write this sin cube as a sin square x into sin x. Here it is a sin square x into sin x dx. ओके, केअरफुली पहा. कंपोजिट फंक्शनचा डेरिव्हेटिव्ह काढायचा म्हणजे कंपोजिट फंक्शनचे इंटिग्रल काढण्यासाठीच आपण सबस्टिट्यूशनचा यूज करतो. ओके, आता इथं काय कॉस अंडर रूट कॉस एक्स आणि साइन क्यूब एक्स दोन्ही कंपोजिट फॉर्ममध्ये आहेत. मग तुम्हाला काय पाहिजे, एकतर कंपोजिट फंक्शनला पुट करायचं आहे, म्हणजे साइन एक्सलाही पुट करू शकता, कॉस एक्सलाही पुट करू शकता, पण डी एक्सच्या मल्टिपलमध्ये डेरिव्हेटिव्ह कशाचा आहे त्याला पुट करायचे. मग डी एक्सच्या मल्टिपलमध्ये साइन एक्सचा डेरिव्हेटिव्ह काय कॉस एक्स, या कॉसला बाहेर काढताच येत नाही. देन पुन्हा कंपोजिट फंक्शन कोणतं आहे कॉस एक्स, कॉस एक्सचा डेरिव्हेटिव्ह काय मायनस साइन एक्स, पण याच्यातून साइन घेता येते बाहेर, हे साइन घेतलं. ओके, नाव हिअर पुट कॉस एक्स इज इक्वल टू टी, बट इट इज अ साइन स्क्वेअर, सो हिअर वी कॅन राईट 0 to 2 pi under root cos x into 1 minus cos square x, it is a sin square x, and into sin x dx. Then put cos x is equal to t, and therefore we can write sin x dx is equal to minus dt, because the derivative of cos x it is a minus sin x, derivative of cos x minus sin x is equal to dt by dx, dx इकडे घ्या minus तिकडे घ्या. Then and here it is a substitution definite integral, and we can change it is a limit of the function, it is a when x is equal to 0, see carefully, when x is equal to 0, cos 0, the value of the cos 0 it is 1, therefore t is equal to 1. When x is equal to 2 pi, that is a 360, again t is equal to 1, that is a limit t is equal to 1, t is equal to 1, upper limit is 1 and lower limit also 1, both are the same. Here upper limit and lower limit, upper limit is a greater value and lower limit is a lowest value, but there are the both are the same. Okay, and in the definite integral you can solve integral, then upper limit minus lower limit, upper limit is a greater value and lower limit is the lowest value of the x, upper limit minus lower limit, but here both are the same, upper limit and lower limit, then upper limit minus lower limit both are the same, that is a calculation, it is a 0. Okay, and here it is a properties of the definite integral. There is a first property, when the upper limit and lower limit are the same, then the value of the integral is 0. Okay, here you can see the property of the definite integral after completion of this article. Okay, after completion the second example in this exercise we can learn the properties of the definite integral, and there is a first property, when the limits are the same, then the value of integral is 0, because the method is the fundamental theorem of the integral calculus, it is upper limit minus lower limit and both are the same and there is a subtraction to 0. Okay, now therefore here integral is equal to 1 to 1 under root t into 1 minus t square into minus dt. Okay, here minus we take the outside the integral, here it is a t to the power 1 by 2, we multiply t to the power 1 by 2 and here t to the power 1 by 2 into 2, that is t to the power 5 by 2. Okay, and both the integral we can solve by using the integral of x to the power n and then put the limits, and then the value of limit is 0. Here we can write directly 0. Okay, here it is an integral a to a f of x dx is equal to 0. Okay, when upper limit and lower limit are the same, then the integral is 0. If in this example, in case the values of upper limit and lower limit are the not same, then how to solve this integral? Okay, here it is a t to the power 1 by 2 into 1 minus t to the power 2 and it is minus dt, we can write here minus t to the power 1 by 2 and minus t to the power 1 by 2 plus 2, it is 5 by 2, and here both the integral we can solve by using the x to the power n, here minus as it is t to the power 3 by 2 upon 3 by 2 minus 5 to, it is t to the power 7 by 2 upon 7 by 2. Okay, and here limit, okay, जे लिमिट तुम्हाला क्वेश्चन मध्ये दिलेली असेल, ओके, सारखे नसले तर, ओके, इफ द लिमिट्स आर नॉट इक्वल, if here it is a 0 to 1, okay, here it is a 1, okay, if here it is a given that pi to or it is a pi by 2 to 2 pi by 2 to 2 pi, then it is a cos pi by 2, it is 0, therefore it is a 0 to 1, then it is 0 to 1 and put the value of the limit in this integral. Okay, here upper limit and lower limit are same, so we cannot calculate, directly write the integral is 0. Now we see next example. Integral of 0 to pi by 2 1 upon 5 plus 4 cos x dx, 1 upon 5 plus 4 cos x dx. Now here see carefully, integral 0 to pi by 2 1 upon 5 plus 4 cos x dx. Now how to solve this integral? This integral is in a type, and type is, it is a 1 upon a plus b cos x, and the solution method is put tan x by 2 is equal to t, dx is equal to 2 dt upon 1 plus t square, and cos x is equal to 1 minus t square upon 1 plus t square. Okay, now here put tan x by 2 is equal to t. Therefore dx is equal to 2 dt upon 1 plus t square. Here it is a cos x, okay, and the cos x is equal to 1 minus t square upon 1 plus t square. Again it is we use the substitution and it is a definite integral, so change the limit. When x is equal to 0, x is equal to 0, 0 by 2 it is 0, t is equal to 0, t is equal to 0, and when x is equal to pi by 2, see carefully here, when x is equal to pi by 2, pi by 2 upon 2, that means pi by 4, it is a tan pi by 4, and then t is equal to 1, tan pi by 4 is 1. Now the original limit it is a 0 to pi by 2, now here after substitution it is 0 to 1. Now integral 0 to 1 dx, it is 2 dt upon 1 plus t square whole to the upon 5 plus 4 into 1 minus t square upon 1 plus t square, and then it is integral 0 to 1 2 dt upon 1 plus t square whole to the upon here 5 plus 5t square plus 4 minus 4t square. See carefully, 1 plus t square multiplied by this 5 and this 4 multiplied by 1 minus t square upon 1 plus t square. Here upon 1 plus t square upon 1 plus t square get cancelled. Integral 0 to 1 2 dt upon 5t square minus 4t square, it is a t square, and plus 9. Okay, again it is a special integral. Then 2 can be written outside the integral. It is a 0 to 1 upon t square plus 3 square dt. 2 outside the integral, 1 upon t square plus 3 square. Then 2 into 1 upon x square plus a square, it is a special integral 1 by a tan inverse x by a, 1 by a tan inverse x by a, that is a t by 3, and here 0 to 1. Then it is a 2 by 3 constant, put the limit, tan inverse of 1 by 3 minus tan inverse of 0 by 3, it is a 0, okay, and then it is 2 by 3 into tan inverse of 1 by 3, it is a 0, 2 by 3 into tan inverse of 1 by 3, it is the last answer of this question. See carefully this.